but we're going to start looking at where could these matrices be used, what is the purpose of matrix multiplication, how could it be used, and where could it be used, and how does it work. So here we have a company that supplies balls, bats, and gloves to different sporting stores. And the following table here indicates the number of items sold to different stores. So we've got a chart here. Store P is buying 70 balls, 30 bats, 22 gloves, and so on. We also know that balls cost $8 each, bats cost $30 each, and gloves cost $75 each. So what a matrix does is it lets us organize our data. So this total order from these 4 different stores, we could write as a matrix. So if I call matrix A, and one of the things that we'll do with word problems, can you see that this is going to be a 4 by 3? And one of the things that we sometimes do for matrices, just to help us remember a little bit about what each of these things stood for, is we might have abbreviations. So store P, Q, R, and S, and great. Balls, I'm going to make a circle for balls, B for bats. Is that bad? Should I write bat and ball? Yeah? Okay. So usually we try to make some sort of abbreviation that would be shorthand for it. Unfortunately, both of those words start with B, and then they both go B-A. So you might just write a ball, bat, and gloves. And then you just write the numbers in. So 70, 30, 22, 60, 70, 50, 20, 15, 40, 19, 24, 12. So that's our matrix A. If we want to write the cost per item, we can make that a matrix B. And it says to make this as a column matrix. Okay, column matrix has one column. I'm going to put a price sign there. And what ends up happening that's very important for all work that you're going to do with real life problems using matrices is that since my first matrix A here, I went balls, then bats, then gloves, I'll want to keep that same order when I make my next matrix. Even though it's a column matrix, the order in that column is going to be important. So balls cost 8, bats cost 30, and gloves 75. Those are expensive gloves. They're like, yeah, a leather of an extinct animal or something like that. The skin of a unicorn glove. Nice. On the last page, just having this. Well, having these two matrices now, we can use matrix multiplication to find out the cost per store. So our matrix A, that matrix was a 4 by 3. Our matrix B was a 3 by 1. So we're going to take our matrix C, and our matrix C is going to be A times B. Remember, A was a 4 by 3, and B was a 3 by 1. And underneath these, I'm going to say the A, the 4, stood for P, Q, R, S. The 3 stood for balls, bats, gloves. This 3 stood for balls, bats, gloves. And the 1 was the cost. So if we multiply these together, And this is where we would use our calculator. So we would go to our calculator. If you want, can you plug in matrix A into A, matrix B into B? Then if we take A times B, what we're going to get as an answer is going to be a 4 by 1. The 1 is going to stand for cost, and the 4. So normally what do stores do in this situation? They have something where they just go, okay, this store ordered this many balls, this many bats, this many gloves. We multiply that by 8. We multiply it by, what were the numbers? 8, 30, and 75, right, for that unicorn glove. And once you have that, if you want to know the total amount owing, you would add those 3 things up, and that would be the bill. What the matrix multiplication does is it allows you to do all of those calculations all at once in one calculation, if you have a program that can do that, because you have your matrix from your orders and your matrix of your costs. You just boom, put them together, and you get your totals right away. So the idea here is it might be quicker if you knew how this worked than doing each one separately. You could just input it into a computer, tell it to do this, and then it could spit out the results. Someone have the results yet? So 31, 10, 25, 05, 28, 10, and 2500. So if we multiply things, A times B, we put matrix A into our calculator, B into our calculator, we get our answer. We just named that C in our notes. If we want to use that answer later on, what we can do is right above your on button is a store button. You can go store. What do I want to store this as? I can go back to matrix, pick number 3, matrix C, and now all of those answers will be put into your calculator into matrix C, so you don't have to retype them. So now we've got matrix C as all of our answers. So these are the total amounts due by each store. Of course, now you want to charge them an additional shipping charge. So their total order, 2% is going to get added onto that. So if we call that a matrix D, we could get matrix D by just multiplying matrix C by 1.02, because that would add 2% to the original total order that you have. So we have now on our calculator, we can just go 1.02 multiplied by, you can either select matrix C. Did that work? No, it didn't. Didn't do that. So I'm going to go to matrix. I'm going to go to number 3 to matrix C and push enter. And we get all of our answers that way. Ooh, nice. There we go. Really easy to read. And then, of course, if you wanted to save that, we can now store that one. Since we call that matrix D, I'll store it in there just so we have that for later as well. Because you don't know if you need that calculation later on or not. So what is the amount owed to Burgess by each store? Well, that's how much we got that 2% shipping charge. We're not going to charge them any other taxes, are we? Yeah, we should. Especially the special 30% unicorn tax for using unicorn skin for leather. The unicorn tax, very rarely used. Yes. Yeah. You use unicorn gloves for catching rainbows. Yes. So we figured that out. Find the total amount owing to Burgess. Well, you could find that total amount by just adding up all of these answers that we got in D. If you wanted to figure out a matrix multiplication to add them all up, we could. Because D right now is a 4 by 1. Oops. So for finding the total amount, we could take total. We could take matrix D, which is a 4 by 1. And I could multiply it by 1, 1, 1, 1, which would be a 1 by 4. How big is my answer going to be? A 1 by 1. Can you see when those ones turn and hit everything, they just add everything up? So we could do that. Or in this case, it might be just quick to add them all up in total. But if we wanted to, we could go to our matrix. We could make matrix E a 1 by 4 with all ones. And when you take matrix E and multiply it by matrix D, it adds them all up and we get the total amount owing to the company. So what matrix multiplication can do for you is probably the most important thing is once you make a bunch of matrices for the data that you have, this multiplying by scalar isn't that exciting, but this one is the key idea here. If you can make matrices where the rows in one of them match up, with the columns of the other one, and the items are the same, then multiplying will give you a new matrix that relates to other things, whatever's the outside. So as long as your rows and columns match up and you multiply things together, then you can create new matrices, and those new matrices can give you other data. So depending on how many matrices you want to make, you might be able to get a bunch more data as a result. Yes? Here? For the total, oh, we did this one right here. I just showed that if you wanted to add something all up, if you multiply by 1, 1, 1, 1, that's a 1 by 4. And that multiplied by a 4 by 1 will give you a 1 by 1. And then that, when you multiply this 1 by 1 by D, you're just multiplying each thing by 1 and adding them all up. So it's a way to add up a thing quickly if you wanted to use matrix multiplication. However, it might be just as easy in this case to actually just add them up. Okay, I want you to try this one. If you called this set of data matrix A, it makes it a 3 by 2. Well-sick carrier, grades 11 and 12. And this one, matrix B. Again, what is really nice here is this column matches up with that row and they're in the right order. So when we multiply A times B, not only do these middle numbers match, but they have to match and represent the same thing. Because you can take word problems and you can multiply matrices together that the matrices are able to multiply together because the numbers match, but the things don't stand for the same thing. So you get answers that really mean nothing whatsoever. So it's really important that not only do those middle numbers match, but they represent the same thing. And here, they represent grade 11 and grade 12. As a result, our outside numbers are WSC and MF, and we can put that in, and if we round those numbers, we now know that there are 38 females that are well, 79 males that are sick, and 76 females that are carriers, so we could use that information to solve this. If you want to start reading the next one and seeing how you would take something that doesn't give you data, how you would put that data into matrices. Right. It is a lot of capital letters.